Okay, today we're going to talk about half-life, which has to do with radioactive decay, and we're going to learn how to do simple calculations of half-life, as well as calculate starting amounts and ending amounts during radioactive decay. The first thing is to understand what a half-life is, okay? So reading the definition, it's the time required for a quantity, usually a radioactive quantity, to fall to half its value measured at the beginning of the time period. So if you start out with a nucleus on the left, one half-life later, half of it will be gone. Okay, and half-life occurs with most forms of matter, but it happens more quickly in radioactive substances. Okay, we are going to do some simple half-life problems. Usually in honors, we do more complicated ones using natural logs and things. But right now, we're going to use a simple number line approach to calculate half-life. And we have two sample problems here. The half-life of radium-222 is 38 seconds. If you want to pause this and read it yourself, why don't you do that now? How many grams of radium-222 remain in a 12-gram sample after 76 seconds, after 114 seconds? Okay, the way I solve this problem is I draw a number line. Okay? And I start at the beginning number, okay, with 12 grams, because that's what I'm starting with at time 0. Okay? And I want to know how much is going to be left after 76 seconds, after 114 seconds, okay? So knowing what I know about half-life, after one half-life, okay, after one half-life, which is 38 seconds, right, I will have 6 grams after one half-life. After two half-lives, now I will have half of that, which will be 3 grams. Now, 38 seconds, another 38 seconds will be 76 seconds. So the answer to this question here will be I will have 3 grams. Now they're asking after 100 grams. So after another half-life, half-life number 3, I will have 1.5 grams, okay? That's another 38 seconds, which would be 114 seconds. And that would mean I would have 1.5 grams. So that would answer that question. So you can see how I use a simple number line to solve this half-life problem. Now let's look at the second half-life problem. Okay, this is kind of like still a number line problem, but we're going to work backwards. Okay, and I hope you can see my writing. I do still have my cast on, so it's a little difficult. Okay, so it says if the passing of 5 half-lives leaves 25 milligrams of strontium-90, how much was at the beginning? Okay, so now I'm working backwards. So at the end here, I have 25 milligrams, okay? Now that means after half-life 5, that's at the end of half-life 5. So at the beginning of half-life 5, that means I had 50, right? Because I'm working backwards. At the beginning of half-life 4, I had 100. At the beginning of half-life 3, I had 200. At the beginning of half-life 2, I had 400. And at the beginning of half-life 1, I had 800. So the answer to this problem, working backwards, is I started with 800 milligrams of strontium-90. Okay? And the last thing I'm going to show you is just graphically what's happening during half-life. You can see as you increase in half-lives, you are accumulating daughter isotopes, and the parent isotopes are decreasing. Okay, so that's all you really have to know for half-life at this time. Thank you.